Hi everyone. So today for this week for class, we had to pick an illusion and describe the illusion and explain what's happening in the illusion. So the illusion that I decided to do was the motion effect, or the waterfall illusion is what some people call it. So I will show you guys the illusion. So basically when the illusion is happening, you're going to stare at the red cross in the little blue circle. And then after looking at that circle, it should Buddha image, like it should alter the Buddha image, and it should make it look like the Buddha image is like moving around and kind of like either like zooming in or zooming out. After looking at the little red cross, and while the like circle is spinning, and the reason that it does this is because the motion effect is a powerful illusion of motion in the visual image caused by prior exposure to motion in an opposite direction. So it's like when we look at an image, but our eyes were just focusing on an image coming in a different direction. And this is often explained in terms of fatigue of the class of neurons encoding one direction. So it is, however, more accurate to intercept this in terms of adaptation or like to gain control. These motion detectors are not in the retina but in the brain, which is kind of like something that like we mistake is like thinking that it's all in our eye, but it's actually in our brain when we like have this illusion and get like kind of thrown off by this. And the illusion almost certainly originates in the ventral cortex and arises from the selective adaptation in cells tuned to respond to movement direction. Cells responding to the movement of the Buddha image of the circular of like the circles moving suffer a reduction in responsiveness while like the thing is like moving in it, like while it's moving out, while it looks like it's like stretching, so that during competitive interactions between detectors, outputs false motion signals arise. So like that's like when you're then looking at the sitting image, it like puts out false detectors and then it makes you think that it's moving, but it's not. And then the result is the appearance of motion in an opposite direction when one later gazes at the image. The adaptation is not confirmed to just one population of cells, but probably occurs at several curricular sites and reflecting the multiple levels of processing involved in visual motion analysis. And the effect is unlikely to be caused by neutral fatigue, more like the MAE, and similar adaptation effects provide a form of error correction or coding optimization or both. So basically like our eyes like see the moving image and we're focusing on something within the moving image, and then our brains like get so tripped up and they almost like fatigue when we look at something else, because like our brains are like taking a second to kind of like readapt to the new image and the new, and like our sensors are kind of readapting to the new motion, and so you almost get like a lag in your brain, and that's why it like looks like the image is moving when it's really not after seeing an image as moving. And this works if you look at anything after watching that like little circular thing, like after you watch something like that, and you could look at your wall and it'll look like your wall is moving, or you could look at your hand and it'll look like your hand is moving, because it's not just the image, it's the motion that is fatiguing your brain. So that is the illusion that I decided to pick for this week and my explanation on it.